Some packages just arrived in the mail with some parts and some tools. I was very happy to find some tube sockets that are exactly the same as the original. Now you might be thinking, well, isn't that a bad thing because the originals are prone to failure? Not so much these, I think. In fact, all the 9-pin tube sockets on this board are actually okay, but I have a few other of these sets to restore, so I picked up a few. I think they were 90 cents each, so figured better to have them and not need them than to need them and not have them. And I also have 7-pin versions, and these are higher quality than the ones on here. In fact, they're 7-inch versions of these guys, which are plastic, unlike these, which are some type of resin, plasticky material that break apart. There's a couple wafers here with the pins in between them. They just don't really hold up very well. Now, the only versions of these I had were with the tube shield, which is kind of a shame because they cost a bit more. I think those are $2.50 each, and I don't actually need the shield. I don't think it'll hurt to leave it on, though. Just like the originals, these have a center lead that comes out. And on these two 7-pin sockets, they are actually soldered to the bottom. They are actually grounded, I believe, which provides some shielding to the pins. But on the one that was broken, that center actually goes to nothing. So if I use a shielded one, that center pin and the shield are actually not even connected to anything. So I don't think that'll cause a problem. Otherwise, I could unbend these crimps around the perimeter there and cut this and pop the shield off. Regardless, it fits in just perfectly. Now, the other stuff that arrived is I got a nice new set of Exolite tools, which are made in the good old US of A. Nice quality, good stuff. My pair of flush cutters I've been using there, the jaws are getting pretty grungy. A lot of dings in the nippers there, so needed a new pair. And these, I got two pair. One has serrated teeth and one doesn't. The pair I've been using have serrated teeth, and the problem with those is when you're using these to bend component leads, the serrated teeth can kind of gouge up the leads a little bit, so I'll be using the flat ones from now on when I need to bend component leads. Another thing I got is one of these guys, which is a soldering iron tip cleaner. I've heard good things about these, I've never actually used one. What it is it's brass shavings in this nifty little container, and you just stick your tip in there to clean it off. All these years I've been using a damp sponge, but I thought maybe I'd give this a try. And finally, this stuff, which is pretty damn expensive. Although I found a decent price, I thought. A lot of places are charging over $100 for one tube of this, whereas I think I paid $67 for this. A lot of money, but on the other hand, this should last me a long time. Now, what is it? Well, it's a type of silicone caulking or adhesive that has good high voltage insulating properties. I will be using it to patch up the flybacks. On, I think, all my Predicta sets, the coating on the flyback is cracking and flaking off. It's not wax, I don't think. It's some sort of black potting material. Maybe it's tar-based or something, I don't know. But I saw another guy who restored a Predicta holiday set, and he used this, and he was really, really happy with the results, so I figured I'd give it a try. In the end, I decided to play it safe, and I did remove the tube shield. I'm concerned that it might form some type of signal coupling or whatnot with the internal tube elements, so there it is, soldered in. Then I started to explore more with these hybrid module couplate things, And I just popped this guy out, which is K6 on the schematic here. I rejiggered that schematic on the sheet of paper here to correspond with the pins as they're laid out on the device. And the only thing I can check with my ohm meter is between pins 1 and 2. We have a 4.7K and a 47K in series. Add those together, it should be 51.7. And what do I have? 70.7. That's pretty far off. That's something like 40% high. So I am leaning towards replacing this guy. Something else I can test on this guy is at least one capacitor. One on pin 7 there. If I hook up a capacitance meter between pin 7 and 2, I should be able to get 3,300 picofarad. And I guess between pins 3 and 4, these two guys are in series, and when you have capacitors in series, it actually cuts capacitance down. If those were both 1,000 picofarads, you would measure 500 picofarad if you had 2,000 picofarads in series. So we got one to 1,200. It should be a little bit higher, something like 550 maybe. So I can check that. And possibly this guy. That's got a resistor in series, but the capacitance meter still might be able to read that as 330 picofarads if it's good. I'm not sure about that. Alright, so I will fire up my capacitance meter and give this a shot. Now, I already am inclined to replace this, but I'm curious to see if I can test these at all. I'm going to be using my Simpson 383A capacimeter for these tests. First thing you want to do is short the leads together and make sure you've got the line adjust on 0 there by adjusting this control, and we do. And now I want to check it with a brand new mica cap just to see how well this meter is working. I haven't used it in a little while. I've got a 2200 picofarad mica cap. So let's give this a try. So we're in 1,000 picofarad range, so we're off the scale. Go to another range here. And that's pretty darn good. We're on 2.2. And you multiply that out, and that's 2,200 picofarads. Alright, so getting back to this couplet here. So if I put the meter leads on pin 2 and 7, we should get 3,300 or thereabouts. So let's see what we get. Wow, that's really, really off. That's about 4,400. That's far cry from 3,300. Oh, to the heck of it, let's go between pins 3 and 4. I was guesstimating it should be somewhere around 550. So now we can go down a range. Right about 500. So that doesn't tell us the whole picture again because I can't check those two capacitors independently, just in parallel. But it seems reasonable. And now I was thinking maybe if I put the meter leads on 2 and 4, I can check that capacitor, even though it's got a resistor in series with it. So let's do that. And it should be around 330, and yeah, we're about 1,000 picofarads or more, actually about 1,500 picofarads. So that capacitor might be bad, or the resistor's throwing it off. I don't know, but regardless, for sure, that capacitor is measuring much higher than it should be. So not only have the resistors gone up in value, at least one of these capacitors is pretty far off in value, so I'm definitely going to rebuild this. Now, if you're wondering why don't I just go ahead and rebuild all of them and be done with it, well, one of the issues I have to contend with is I don't know what is really in here. I tried dissolving this coating with some acetone and paint thinner and no effect. It seems to be some type of ceramic coating, very resistant to anything. So all they tell you on a schematic and in the parts list is just what the internal values are. I do not know what the resistor wattage should be, which is not that big a deal. If I go with 1 watt resistors, I'm sure that will be more than sufficient. Probably half a watt would be sufficient. Capacitors, though, that's another matter. Should they be ceramic? If so, what should the temperature coefficient be? Should they be mica? Should they be plastic in some cases? Or we like paper, I should say, because I didn't have plastic back then. No, I can make some educated guesses. I would think that if I go with some quality mica caps like these, rated probably 500 volts would be good enough. That should work quite well. Mica caps in general are the most stable capacitors you can use. But you know, they must have done this for a reason, because there's a whole bunch of discrete parts, resistors and capacitors all over the circuit board. Why did they choose to group these components together in whatever order these are, and then coat them? So maybe so they thermally track. Is there a ground plane in here? Who knows? About all I can go by is just a few discussion threads online and forums from people who have worked on these sets before. It seems like generally, though, that people don't need to rebuild these. It's just this other guy that's problematic, and sometimes the one with the vertical integrator. So that's why I was talking about using a socket. One, so I could pop the original in and see if it actually does work okay, and two, to try out various replacements using different component values, or I should say different types of material like ceramic caps versus mica caps and so on. Well, it should be interesting to experiment, I hope. So, yeah, we'll see. We'll see. I guess I'll go with mica caps and 1 watt metal film resistors for now. While I have this meter out, I thought I'd show you something else I think is kind of interesting. In addition to capacitance, this meter can also check resistance, specifically mega ohms. Very, very high. It goes up to like 1,000 mega ohms, or infinite really. But you can actually read 10, 20, 30, 40, 50, 100 mega ohms. So it can check for very high resistance, or in other words, you can check for leakage in capacitors. Now, first off, let's take a look at a modern capacitor. So right now it's measuring infinite resistance because the two leads are not connected. If I put it on this capacitor here, still infinite. By the way, when you're doing this, don't grab both leads at the same time. You get a little jolt. Well, let's check a modern plastic film capacitor. Oops. And infinite. Now, let's check a grungy, old, nasty paper cap. Oh, let's do this guy first. These are pulled from an old Motorola TV. I already tossed the ones from the Philco, but I'm sure they would test just as bad. Look at that. Only about 3 mega ohms. Very leaky capacitor. Check this guy too. even a little bit worse. So that's why you replace these capacitors. They just stink.